Greetings, students. This is Dr. Sutton, and I'm going to discuss your study guide with you. The first problem is a basic division of fractions problem where you take 3/4 and it's being divided by 1/2. 3/4 should be multiplied times the reciprocal of 1/2, which is 2/1. If I multiply my numerators, I get 3 times 2. And by multiplying my denominators, I multiply 4 times 1, and my answer is 6/4. I can literally change this 6/4 to a mixed number because it's an improper fraction by dividing 4 into 6. 4 will divide into 6 one time, with 2 left over 4. This can be reduced to be 1 1/2. This next problem is a word problem about Mary, who has 2.5 yards of ribbon. She wants to make 5 hair bows with it. How much ribbon will she need for each bow? Well, for this particular problem, we need to underline keywords, which is one of our AVID strategies, and highlight keywords as well. And we literally can, in this problem, highlight the data, which will deal with the numbers and words that are associated with the data, and we can highlight a keyword such as the word each. Marking the text is going to be very important this year. So with that being said, this is a division problem where we're taking 2.5 and we're dividing it by the 5 bows. If you notice when I do this, I already put my 5/1 because I want to make sure that I know that I'm always have to deal with a fraction when I'm dealing with another fraction. But 2.5 is a mixed number, so I want to change that into a fraction as well. In order to do that, I must multiply the denominator in the fraction times the whole number and add that amount to the numerator. This will give me 5/2. Now I will take my 5/2 and I will divide that by 5/1. If I multiply times the reciprocal, 5/2 times the reciprocal of 5/1, I get 1/5. If I multiply my numerator times numerator and denominator times denominator, I get 5/10. 5/10 can be reduced, and that becomes 1/2. So if I had to say a sentence, I would say that Mary would need 1/2 a yard for each bow. And that is 1/2 yard of ribbon for each bow. Number 3 asks, which of the following expressions can be used to find the quotient of 5/7 divided by 3/9? Again, the word quotient is going to be important in this particular problem. So with that being said, I got to look for something that not only represents a quotient, but also represents how we normally do division with fractions. 5/7 divided by 3/9 can be solved by multiplying 5/7 times the reciprocal of 3/9, and that would give us this process of 5 times 7, which is numerator times numerator and denominator times denominator. I can immediately eliminate B and C because they have addition and subtraction in their procedures. So the best answer is going to be A. The next question is, how many 1/3 servings are in 5/6 cups of rice? Well, we have a new word set of choices here with how many. When we have how many and we have the other words are in, we literally have to take that second number and have it divided by the first number. We need to know how many 1/3 servings are in 5/6. So that gives us 5/6 times 3 over 1, which is the reciprocal of 1/3. That gives us 15/6. And that gives us 2 3/6, which could be reduced to 2 1/2. Students, you could have cross-reduced to save yourself some time with reducing at the end, and you could have taken 3 and divided it into itself, which the greatest common factor of 3 is 3, and 3 divided into 3 is 1, and divide 3 into 6 and get 2. So if you rewrite that, that would have been 5/2 times 1 over 1, and that would be 5/2. Well, of course, that's an improper fraction, and if you divide 2 into 5, it goes in there 2 times with 1 left over 2, and we still get the same answer. Just know that cross reduction or cross reducing is also an option for you. Long division is also of multi-digit numbers, is also one of your standards. So you, in this particular problem, when it says what is the quotient of 528 divided by 24, well, quotient is the answer to a division problem. 528 is what we're going to divide 24 into. In class, we learned that the divisor divided into the dividend gives us the quotient. So in this case, we're dividing 24 into 528 to get our quotient. 24 is too large of a number to divide into 5. So now we need to see if 24 can divide into 52. Since 24 can't divide into 52 evenly, I have to think about numbers that might be smaller than 52 that 24 can divide into. So the closest number that 24 can divide into evenly is 48. 24 times 2 is 48. If I subtract 48 from 52, I get a 4. I need to bring down my 8, which is a part of our process that we learned in class that we called divide, multiply, subtract, and bring down. We're at the phase where we just brought down the 8, and now we need to see if we can divide 24 into 48 evenly. Well, we just learned that we can divide 24 into 48 because 24 times 2 is 48. So 24 times 2 is 48. And of course, when we subtract, we get a 0 and we are done. There is no remainder. The next problem reads, what if Mary wanted to make 4 hair bows and each one needed 3/4 of a yard of ribbon? Exactly how much ribbon would Mary need? In this particular problem, we actually need to underline the key words here as well. Specific data are 4 hair bows and 3/4 of a yard of ribbon. The how much ribbon in this particular case actually is a product. So what we're going to do is to multiply that particular number times 3/4, the number 4, in order to get our answer. So what we would do is take 4 over 1 times 3/4, which gives us 12/4. And if we take 12 and divide it by 4, we get 3 yards. Okay, students, we have 2 more problems to go. How many 1/4 groups are in 2 1/2? Draw the model and solve. This is another case where the word how many is in the problem. So I'm literally going to take 2 1/2 and make my model represent it being divided by 1/4. Okay, so this is almost like one of those, it is one of those where it's reversing. So you want to make sure you're paying attention to the fact that it's reversing. To model 2 1/2, I actually can take 2 rectangles, full rectangles, and then take a third rectangle to represent the fact that it's not quite a full rectangle to model the 2.5. I'm going to shade in those 2.5 just to make sure that we're keeping up with that information. The next thing I want to work on is the 1/4. In order to work with the bottom portion where I'm dealing with my 1/4, I have to make sure I understand my fractions. If I take a fourth plus a fourth and continue writing my fourths down, I would notice that just based on equivalence, 1/4 plus 1/4 is 2/4, which is a half, and the other 2/4 will make a whole. So 1/4 plus 1/4 plus 1/4 plus 1/4 is equal to 1 whole. So that just helps me to keep track of what I'm doing here. So I know that I can do another 1/4 here, another 1/4 here, another 1/4 here, and another 1/4 here under the second box. And under the third box, I would do another 1/4 and another 1/4. Now I would stop here because that's where my shading stops. So with all that being said, the number of groups that I'll count would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there would actually be 10 1/4 boxes or groups, as has been stated here. But in order to really hone in on that to make sure it's true, I can use my same model of keep, change, flip, or multiply and times the reciprocal. Well, I literally cannot multiply 2.5 times the reciprocal of 1/4. I have to change that mixed number to its improper fraction form. This gives me 5/2 times 4/1. That gives me 20 divided by 2, and 20 divided by 2 gives me 10. So it makes mathematical sense based on my model and on my calculation. The final problem is about Joe. It says Joe says 3/4 divided by 1/2 is 3/8. Billy says 3/4 divided by 1/2 is 6/4. Who is correct? Explain your reasoning in terms of division and multiplication. When thinking about Joe's process, it looked like he multiplied numerator times numerator, which is 3 times 1, and got 3, and 4 times 2 to get 8. While on the other hand, Billy looks like he did multiplying times the reciprocal because he wrote 3/4 divided by 1/2, and then he did 3/4 times 2/1 gives you 6/4. If I were to choose, I would say that Billy is the most correct in this particular example based on the procedure he used for division of fractions. So my sentence would look like this. I could write, Joe must have used the multiplication of fraction rules only. Billy, on the other hand, started with division and multiplied by the reciprocal. Billy is the most correct so far. Keyword being so far. Is there something that Billy could have done to make his problem even more precise? Yes should be your answer. Billy could have divided 4 into 6 and got the mixed number 1 and 1/2 because 4 divides into 6 one time with 2 left over and gives you 1 2/4, which can be reduced to 1 and 1/2, which we saw in a previous problem. Thank you all for listening and keep working hard on those problems. Remember that growth mindset is taking you to the next level. If you don't understand something, you're trying to figure out ways to make sure you understand. Have a good day.